Okay, so now what's going to happen once tomorrow? I'll spend a little time and kind of get up to speed on GitLab a little bit. All of the code that I'll be creating here will be eventually uploaded to the repository that I added you to. So if you added me to your repo, I got an email about that, and so I added you to mine. Did you get an email that you were added to mine? Okay, so in order to distinguish my code from yours, my project will be named class code, whereas yours will be simply CS2173. Okay, that's to distinguish them. What you'll be able to do is you'll be able to basically download mine and update it when I do an update. And you'll be able to keep it as a separate, what my recommendation is, keep it as a separate project. So you'll have your project, you'll have my project, and then you'll be able to kind of, as long as you keep those separate, then you'll be able to kind of distinguish the two. Because if you notice, I asked you to add me as a developer for yours. What that will let me do is that if you're, like say, if you're working on a project or something and you absolutely kind of hit a brick wall or something like that, then I can sort of fix it and actually commit it to yours. Whereas I added you as a reporter to mine. Okay, why is that? What's the difference? A reporter can see but not change. So you'll be able to see my code but not change it. So I'll be able to see your code and I'll be able to change it too. So the reason that's helpful too is that if you, let's say you have an assignment where you get 95% of it done, but there's 5% that's kind of an error. Well, and it's time to submit it, or you have to move on to something else. Well, then you can at least submit. You can at least push what you've done, and then I can kind of figure out what you've, where the mistake was and fix it, and then actually kind of upload it. So it won't necessarily help the grade on that, but at least you'll be able to kind of have something corrected. Because say, why did something not work? Well, maybe there was something that you weren't completely getting. And as you've noticed, it's a fairly complex sort of thing, and so sometimes things happen. And unlike myself, where every time I write a line of code, it is absolutely perfect and it never produces an error. And if you believe that, I have a bridge that I can maybe interest you in. Okay. Okay, so here's to clarify what the book was, what we were talking about initializing variables and local variables. So we're inside a static main, a static method called main, whose argument is an array of strings. And the way that Java works is you can have as many of these classes with main in them in your project as you want. Which one does it run? Well, you say, I want to run this one. So what does Java do? What it does is it finds the main and starts from there. If I declare a variable inside here, it is a local variable, and the scope of that variable is within that method. So let's define an int. But remember, for local variables, they always have to be initialized. So what would happen if I forget that? Well, let's print it out. We've already seen, again, so far this is kind of a magic incantation. There's a print line. Okay, so what happens if I try to print a local variable which has not been initialized, or use it in some way? Okay, now here's the thing, is that I get what's called the red squiggly of death. And the red squiggly of death, if you can see, is there's a little red squiggly under here. You see that? The red squiggly of death says that the compiler is not happy. And we want to make the compiler happy because the compiler is not going to let us run our program until it is 100% happy. So what is it unhappy about? Now, this is where NetBeans provides some nice things. Notice over here there's a red exclamation point, which kind of, again, is another indication that the compiler's not happy, and a little light bulb that says, hey, I've got an idea. So what NetBeans, and unfortunately I can't make it bigger, but it's a little pop-up, but if I hover on it, if you can read that, it says variable x may not have been initialized. Okay, so if I do not initialize my local variable, the compiler says, And that's true whether, in this case I'm just trying to print it, but now notice that, okay, now here's a little trick. A comment, you're familiar with the way the comments are done. Again, we'll maybe cover it explicitly. We actually see two types of comments here. One is the /*, and that's kind of automatically produced by NetBeans. We can change that, as they say. And the second is a /*, and those are two different types of comments. This is just a regular comment. This is what's called a Java doc comment. We'll kind of get to that. The third type is the //. You're familiar with that, right? Okay, so now NetBeans has a really cool thing. Say, well, what if I want to comment out something? So here there's a problem, and I don't know what the problem is, but in the meantime, let's just kind of go on, and I'll come back and try to fix this later. Well, if you are on a Windows machine, you type // If you're on a Mac, type // And what that does is that produces that // there. And if I want to turn it off, I just do that again. So // or // toggles between commenting one line or more lines. Like if I highlight some things and I do the same thing, it will do that. That's again just a nice little trick. All right. Now, for local variables, you'll see this in the book, that oftentimes you'll see something like, you'll say something like int x equals 3, something like that. And I'll eventually do something like that, but I deliberately don't in the beginning, because I want to emphasize the fact that these are two different operations entirely. These are two different things going on. And it's important to understand those two differences. What I've done here, by saying int x, I am simply, that's actually not an executable statement. It's just a declaration. I am declaring that the variable x is going to be an int. Here I'm saying the variable x is going to take the value 42. That's an executable statement, and it's specifically an assignment statement. And actually, if you think about it, this is one of the kind of weird things that have kind of promulgated from the early days. That is, if you're used to mathematics, this is kind of a weird thing. In mathematics, if I say if two things are equal, I'm saying that they're equal. Now, after I execute that, they're equal, but this actually doesn't do that. What this says is take the value on the right-hand side and stuff it into the variable on the left-hand side. That's an entirely different thing. And you may not have even thought of that, but or thought of the fact that this on the face of it, that's a ludicrous thing to write. And that's why, like earlier, some languages like R, for example, has like a right arrow that instead. Earlier languages like Pascal had like a colon equal to say, okay, I'm making an assignment, but people kind of gave up and said, okay, so here's. So again, like what I've been trying to emphasize here is again, local variables have to be initialized. Declaration is different than assignment. And just as a final thing, let's declare another variable y, and make it 100. Again, just to, oops, especially the, okay, so x is 42, y is 100. X over y ought to be 0.42, but in fact it is, when I run it, first I get 42, and when I run it, I thought I could, there we go. When I run it, I get 0. So the value of 42 over 100 is in fact 0. And what I want to emphasize as well is that if something kind of comes up for you, like, okay, what does this do, or what happens if I do this? Kind of be a scientist about it, not a computer scientist, but a real scientist. No, not to disparage computer science, but computer science is not a science. In science, we create a hypothesis, we perform an experiment, and then either verify or don't verify the hypothesis. We don't really see that in computer science, but we sometimes see it in programming. So my hypothesis might have been that x over y, 42 over 100, is 0.42. That's my hypothesis. I perform the experiment and I get 0, so I have to reject that hypothesis. That's the science.